Absolutely foundational.
Yeah, and specifically, we want to dig into the difference between positive and negative charge. We've got all your source material here, and our job really is to pull out the key ideas, make this core concept clear.
Make sure you walk away feeling, really solid on this.
Exactly.
And it's important because, positive, negative, they sound simple, right? Almost basic.
Right.
But why we have that distinction, what it actually means, that's crucial. Your sources really show it's the bedrock for how matter interacts.
It drives electricity, magnetism.
Everything from like tiny atoms all the way up to massive lightning bolts.
Yeah.
And the details in your materials, they're pretty fascinating when you get into them.
They really are. We're going to find out based on what you've given us. Things like the history behind the names, kind of surprising actually. Who carries these charges and how these simple plus and minus signs basically run the show with forces. It's all coming straight from the info you provided.
Yeah, think of us as just helping you connect the dots in those sources.
Okay, sounds good. Let's unpack this, starting right at the beginning. What is electric charge, according to these sources?
Okay, so your material defines it as a fundamental property of matter.
Fundamental, okay.
Yeah, it's this intrinsic quality that makes something feel a force when it's in an electromagnetic field.
Ah, okay, so it's built into the smallest pieces of stuff.
Exactly, the elementary particles, the building blocks of everything.
Got it. And the sources stress there are just two types, positive and negative.
Just the two.
But why those names? Is there some deep physical reason it had to be positive and negative?
Well, that's one of the first really interesting points in your sources. It actually comes down to history, a convention.
A convention, not physics.
Well, the physics is real, but the names point back to Benjamin Franklin.
Franklin, like lightning kite Franklin.
That's the one. He was working on this stuff centuries ago, and he had this idea, this theory, that electricity was like a kind of invisible fluid.
A fluid? Seriously, like water?
Sort of, yeah. An electrical fluid. And his thinking, based on experiments like, rubbing things together.
Static electricity.
Right. His idea was if an object had too much of this fluid, an excess, it had one type of charge. If it had too little, a deficiency, it had the other type.
Okay, so more fluid, less fluid.
Exactly. And then he just kind of arbitrarily called the state of having excess fluid positive and the state of having not enough negative.
Well, hang on. So he just picked the names. It could have been A and B or up and down.
Pretty much. The fluid idea itself, we know now that's not how it works. But his labels, positive and negative, they stuck.
That's amazing. So we're using terms based on an outdated model.
We are. And the modern definition, which your sources laid out, is tied directly to that convention, but linked to electrons.